All right, now we will solve some practice questions of arithmetic and geometric progression. Look at this question. It is given in the statement that each year the value of a certain ramp increases by 5%, and the initial value is $10,000 in the beginning of 2005, and you are supposed to find the value at the beginning of 2015. Now, one thing you need to remember for a geometric progression, how to find the value of R from the percentage. If R increases by, if you have this statement that if the value increases by 5%, it means that R will be equal to 1 plus 5 by 100, so you will have 1.05. Similarly, if it is given in the statement that the value increases by 20%, it means that R will be equal to 1.2. And sometimes you will have decrease in the geometric sequence. If the sequence decreases by 20%, it means you will have to subtract 20 by 100 from 1. So the value of R will become 0.8. Similarly, if you have the sequence which is decreasing by 5%, it means you will have to subtract 5 over 100 from 1. So the value of R will be equal to 0.95. Now in this case, you can see in the statement that the value is increasing by 5%. It means that the value of R will be 1.05. And look at the initial value. A will be the initial value. It is 10,000. And you are supposed to find the values after 11 values, because if you start from 2005 and if you go till 2015, you will have 11 years. So the value of n will be 11. And this is the expression for the nth term. You know, A is the initial term, which is 10,000. R is basically the ratio or the common ratio, which is 1.05 for this case, and n is 11. So if you simplify this, you will get 16,288, because you are supposed to give answer correct to the nearest 100. So the nth value will be 16,300 value. It's not the nth value, it is basically the 11th value. So this will be equal to $16,300. Now look at part B. You have an expression for sum up till n terms of an arithmetic progression, which is n by 2 times 3n plus 7. And you are supposed to find first term and the common difference of the progression. Now if you put n is equal to 1, it means you will have just one value. If you put n is equal to 1, you will get 5. S1 is equal to 5. S1, it means that sum of one term. So the first value or the first term of the progression will be equal to 5. Now look at the common difference. You can find S2. S2 means sum of first two terms. And if you sum up first two terms, you will get 13. So you can see that the sum of first two terms is 13. A plus A2, it is 13. And you have just calculated the first term, it is 5. So if you take it over there, the second term will be 8. So first term is 5, second term is 8. It means that the common difference will be second term minus first term. So the common difference will be equal to 3. Now look at the second question. It is given in the statement that first two terms of an arithmetic progression are 1 and cos square x, and show that the sum of first 10 terms can be expressed in terms of sine square x, or in this type where a and b are constants to be found. So we can see that first term is a and second term is cos square x. And you are supposed to find the sum of first 10 terms. So the expression is going to be S10 is equal to 10 by 2 times 10 minus 1 times d. So that will be equal to 5 plus 9, and the difference will be second term minus first term. So that will be equal to cos square x minus 1. Now you are supposed to simplify this. So this will become, that will be 9 cos square x, and 2 minus 9 will be, that will be, yes, 2 minus 9, that will be negative 7. So you will have, that will become 5 9s are 45 cos square x minus 5 7s are 35. And since you know this Pythagorean identity, you know that sine square x plus cos square x is equal to 1. So you can write as cos square is equal to 1 minus sine square x. So you will have 45 minus 45 sine square x minus 35. So that will become 10 minus 45 sine square x. So this will be the sum of first 10 terms in terms of sine x. Now in part B, it is given that the first two terms of a geometric progressions are 1 and 1 by 3 tan square theta. Find the set of value of theta for which the progression is convergent. Now I've told you about the convergent sequence, that basically the r, the absolute value of r must be less than 1. It is given that the sequence is convergent, so r must be less than 1. So you will have, if you find r, that will be second term divided by first term. So that will be 1 over 3 tan square theta minus 1. So tan square theta will be less than 3. Or you can also have tan theta must be between square root of 3 till negative square root of 3. All right. Now if you take tan inverse of square root of 3, that will give you 60 degree, or you can also say pi by 3. So theta is going to be between pi by 3 till 0. Now let's move to the next question. All right, look at this question. You have again you have an arithmetic progression, and sum up till n terms is given as n square plus 8n, and again you are supposed to find first term and the common difference. If you put n is equal to 1, s1 will be equal to 9 and s2 will be equal to 8 2s are 16, and 16 plus 4, that will be 20. It means that first term is 9 and sum of first two terms is 20. It means that the second term is 11. So the common difference will be 11 minus 9, and the common difference will be equal to 2. Now look at part B of this question. In a geometric progression, the second term is 9 less than the first term, and the sum of second term and the third term is 30. Given that all the terms of the geometric progression are positive, find the value of first term. So you have second term, which is AR, you know that second term is AR, and a second term is 9 less than the first term. So if you subtract first term and second term, that will be equal to 9. So this will be the first equation. And now it is given that sum of the second and third term is 30. So second term is AR and third term is AR squared. So this will be equal to 30. It means that A times R plus R square will be equal to 30. And this is the equation 1. Now you are supposed to find the value of A. If you divide both equations, like the first equation is A times 1 minus R is equal to 9, and the second equation is A times R plus R square is equal to 30. If you divide both equations, you will have an quadratic equation in terms of R. So that will give you 30 minus 30R and 9R plus 9R square. So you will have 9R square, and that will be 39. R minus 30 is equal to 0. And let me use my calculator. That will give you R is equal to 2 by 3. So this is the value of R, which is equal to 2 by 3. And if you put R is equal to 2 by 3 over here, you will get the value of A. So A will be equal to 1 minus 2 by 3 is equal to 9, which will give you A is equal to 1 minus 3, 3 minus 2, 1 by 3. So A will be equal to 27. All right, now next question. The first, second, and last term of an arithmetic progression are 56, 53, and negative 22. So in part A, first term is 56. Last and second term, it means A plus D, that will be 53. And last term, it is always, last term means nth term. Means nth term. So you know that nth term of the sequence of the arithmetic sequence is basically A plus n minus 1 times D. It is equal to negative 22, and you are supposed to find the sum of all the terms in the progression. Now first of all, if you simplify these two equations, you will get D is equal to 53 minus 56, so D will be equal to negative 3. Now, first of all, we will see that how many terms do you have in this sequence. First term is 56 plus D is negative 3. So you will have 56 negative 3n plus 3 is equal to negative 22. So you will have 56 plus 3, 59 plus 22. So n will be equal to 27. It means you are supposed to find sum of all the terms in the progression. So you are supposed to find S27, sum of 27 terms. So that will give you 27 over 2 times the first term. First term is 56 plus n minus 1, it means 27 minus 1, and the difference is negative 3. So the sum of first 27 terms, that will be 56, and so that will give you, if you simplify this, let me use my calculator, so that will give you, yes, 459. So this is basically sum of all the terms in this sequence. Now look at part B. It is given in the statement that first, second, and third term of the geometric progression are 2k plus 6, and 2k and k plus 6, find the value of k. Now basically this is first term, this is second term, and this is third term. You know that for a geometric sequence, if you divide any term with the previous term, you will get same number. It is basically definition of the geometric sequence. I've already told you. So here in this case, if you divide third term over second term, or if you divide second term over first term, you will get same number. This is basically called the common ratio. So you can have this type of expression that the third term is k plus 2 divided by second term, which is 2k, that will be equal to second term, which is 2k, divided by first term, 2k plus 6. Now you will have to cross multiply this. That will give you k plus 2 times 2k plus 6 is equal to 4k square. In this way, you will have a quadratic equation in terms of k square. If you simplify this, minus 5k minus 6 is equal to 0. Now you will have two values for this. If you do the middle term breaking, that will be k negative 6 times k plus 1 is equal to 0. We will ignore this one because it is given in the statement that k is a positive constant. So k will be equal to 6 in this case. Now we are supposed to find sum up till infinity. We can see that now first term is basically k is 6, so 2 6 are 12, 12 plus 6 18, so this will be the first term, and this will be the second term. So r will be 12 by 18. It means r will be equal to 2 by 3. So you know the expression for sum up till n terms. It is basically sum up till infinity a divided by 1 minus r. I've just told you that first term is 18 and r is 2 by 3. So you will have that will become 1 by 3. So the sum up to infinity will be 54. All right.